The mean-value theorem stated some relationship between a function f and its derivative. We'll illustrate a little bit of that in the next theorem, theorem 4.9. 4.9 says that if f is continuous on the closed interval and differentiable on the open interval a to b, then the following are true. Number one, if the derivative of x is never equal to 0, let me state it just like it is here. If f prime of x is not 0 for all x in AB, and you need to understand what that means. For every x in AB, the derivative is not 0. So the derivative in that interval is never 0. What does that mean? Well, if it's never 0, it means it's never going to change. If it's positive, it's never going to change to negative. If it's negative, going downhill, it's never going to change to positive. It turns out that f is a one-to-one function in that case. And we'll talk about that again a little bit more in a minute. Well, suppose f prime of x is equal to 0 for all values of x in the interval a to b. Well, that means it's a horizontal line, or we would say that f is constant. It's the constant function. Maybe we could say f of x is equal to k for some real number k. Number 3 says that the derivative, f prime of x, is greater than 0 for all x in a to b. So that means it's always going uphill. So that means f is strictly increasing. I added a couple down more than the textbook did. Let's jump down to number 5 next. So instead of greater than, it's greater than or equal. Well, the textbook calls that an increasing function, where you could have some spots where it's horizontal, where it's constant. I would rather call that non-increasing, but we'll go ahead and go with the book and say, for part 5, f is increasing. Again, non-decreasing would be a better way. Better way to say that. Then, if f prime is less than 0, it means it's going downhill at all times. Never levels out. In that case, f is strictly decreasing. And similar to that, changing the less than, the derivative being less than 0 or negative to less than or equal to 0 means that f is decreasing. Again, a better word for that would be non-increasing. For the proof, you can see the textbook, and essentially it uses the mean value theorem.